Hi, my name is Julie. I'm one of the biochemistry course mentors, and we're going to talk through the quiz on what is fueling Annie's workout. So we know that Annie hasn't eaten in a while. We want to evaluate which of the following things would be true. So we know that when you haven't eaten in a while, your blood sugar levels start to drop. Insulin is something that acts when we're in our fed state, right? And it acts to lower blood glucose levels. So that doesn't really fit with Annie, so we're going to eliminate that one. In terms of glucagon, glucagon has an opposing effect to insulin. So glucagon is something that our body produces when we haven't eaten in a while, and it acts to bring our blood sugar levels up. That would be a good thing for Annie at this point, because that raise in blood glucose levels is one thing that could help to fuel her workout. So we are going to keep that. And where is that glucose going to come from? Well, the body stores glucose in the form of glycogen, and it stores that in the liver. So one thing that glucagon does is it signals to your liver to break down glycogen reserves to release that glucose out into the bloodstream so it can be used. So she is, in fact, going to need to rely on glycogen reserves to get her through her workout since she hasn't had anything to eat in a while. Okay, so the process of breaking down that glycogen is called glycogenolysis. So lysis means to break. In this case, we're breaking down glycogen. Glycogenesis is the opposite, so building glycogen. At this point, right, Annie would want to tap into the glycogen stores and break it down, so we would expect those rates to be high, but she wouldn't want to generate new glycogen because she's actually low on energy stores, so the rates of that would be low, so that's a keeper. This is the reverse, so we would throw out that answer because she wouldn't want to be making glycogen when she doesn't have enough sugar to begin with, and she does indeed want to tap into these glycogen stores and break down that glycogen. So we would get rid of this last one as well. All right. So moving on to the next one, it says, describe how Annie's muscle cell generates ATP early on in her workout. And early on in her workout, we would expect that, she hasn't gotten too tired yet. She still has oxygen available in her muscle cells. So when glucose makes its way into the muscle cell, it's going to be broken down by three steps. So the first of those steps is glycolysis. That step doesn't require oxygen, but the steps that follow do. So with oxygen, this is early on in the workout, glycolysis is going to be followed by the citric acid cycle, and then it will be followed by, the electron transport chain. And that electron transport chain is going to produce a lot of ATP that the muscle cells can use to fuel this activity. Okay. So as Annie gets further along in her workout, her muscle cells get depleted of oxygen. And we want to think about, well, how will ATP production be affected? So when we think of the three processes that happened when oxygen was present, glycolysis does produce a little bit of ATP. So for one glucose, it will generate 2 ATP. The ETC leads to production of around 30 ATP per glucose. Now, these last two steps, citric acid cycle and ETC, they rely on oxygen. When oxygen is not present, so without oxygen, we instead get a process known as fermentation, and the glucose enters glycolysis still. We get production of pyruvate, but that pyruvate is then turned into lactic acid instead. So the pyruvate If oxygen is around, it will kind of get converted to acetyl-CoA, go into the citric acid cycle. But without the oxygen, that pyruvate gets converted into lactic acid. And so without the oxygen, we do get the 2 ATP from the glycolysis, but we don't get the 30 ATP from the aerobic portion of the metabolism. So the amount of ATP that's produced for an individual glucose molecule is going to go down quite a lot, from 30-something to only 2. So as we check through our answers, it would be nice if when we worked out and our muscles got depleted of oxygen, if they produce more ATP, but in fact, they actually end up producing less. It is true, right, that the muscles will generate less ATP and that they will produce lactic acid. It won't be steady, right? So, again, we're going to have a reduction in ATP production, so that one doesn't work. And these are reversed here. So instead of generating 30 ATP per glucose, the muscle cells are now going to be producing just 2. So this answer doesn't really make sense either, since those two things are reversed. All right, so I hope this video was helpful. You're welcome to reach out to our course mentoring team at biochemistry@wgu.edu if you have questions. Thanks so much for watching.